Okay, come. Find the critical points of your function. For this piecewise function, so first of all, we go back to your basic. How to find your critical point? Your critical point. Your critical point can be obtained by first derivative equals to 0 or first derivative is undefined. So if by graphing, you can see critical point also happen at the point of changing graph. Here you have one graph, here you have another graph, here is a point of changing graph. So that point maybe is our critical point also. Alright, this is another linear graph, the changing graph here. So there might be a critical point here. Therefore, with your function here, so first of all, we differentiate your function. So your function, you've got 2. So if you're following the piecewise function here, when you get a piecewise function, we draw out the interval. For more than 0, this is quadratic. From less than 0, this is linear. So when we try to draw, if x is 0, this is linear. When x is 0, y is 2. So this is my y-axis, this is my x-axis, this is x is 0, y is 2. 2 is included. And then this line is increasing. Got intersect. So when y is 0, x equals to -2. We try to draw first. Maybe we have a changing point here. Alright. So for this quadratic, when x 0, another piece here, the y is 2 also. So the y is 2 also. Can you factorize this? Can you do completing the square? X minus 1 square minus -1 square plus 2. So x1, y1, x1, y1. This is your minimum point. Correct? X put in the bracket, then b divided by 2, -1 minus this b square. So x equals to 1, y equals to 1. So this is minimum point, quadratic minimum point. Okay? Alright, so for the first function, for x more than 0, your function is quadratic. When you differentiate 2x minus 2, let this equals to 0 to find critical point. Let first derivative equals to 0 to find critical point. So therefore you can find x is equals to 1. So when x equals to 1, what is your coordinate? We substitute into your function. 1 square minus 2 times 1 plus 2, 1. So therefore, from quadratic here, we find 1, 1 is your critical point. Because we haven't tested anything, we don't know that is maximum or minimum. But from the graph, we can observe, yes, nanti akan dapat minimum point. Daripada graph tu dah nampak dah. So di sini, we have a critical point. Alright? Alright? Then, for another graph, left-hand side graph, when x less than 0, what's your graph? Less than equals 0. Your function is s plus 2. Differentiate it, we get 1. So can we find a critical point here? No, we don't have critical point here. Because your graph here already become piecewise. Graph kamu dah jadi skerat. So kita tak nampak. Dia dah tinggal skerat je, dia sambung dengan graph lain dah. So from here we can't find, kita tak boleh nak buat f prime x sama dengan kosong. Betul? Boleh ke f prime x sama dengan kosong? Tak, dia memang f prime x sama dengan 1. Bermaksud daripada belah kiri graf tu, kita tak jumpa critical point. Alright? So, one more. We have changing point. Keadaan yang macam ini. Keadaan critical point di mana satu graf sambung lagi satu graf. Macam tu. Ada kan? Bila kita dapat piecewise function, so we have one point kat sini. Betul? Therefore, we can analyze at here. At x equals to, changing point here adalah 0. So, when x equals to 0, kita tengok belah kanan, belah kiri. For x more than 0 is your quadratic. Your function is a quadratic. So, what is your differentiable at the point? It was substituted here. So, it can be differentiable equals to -2. And then for x less than 0, differentiable at this point is 1. So, left hand side, right hand side, sama ke differentiable dia? Tak sama. So, di sini berlaku satu critical point lagi. So, you can find your critical point from differentiable concept. Belah kiri differentiate dapat lain, belah kanan differentiate lain, belah kiri differentiate lain. So, kita boleh perasan -2 is not equals to 1. So, your function at the right hand side and the function at the right hand side, they are not the function is not differentiable at x equals to 0. Therefore, x equals to 0 also a critical point. A critical number here. So when x equals to 0, what's your point? What's your y coordinate? Dia nak substitute ke mana? X kosong substitute lah ke sini, betul? So x tambah 2. X tambah 2. Kosong tambah 2. So dapat 2. Maka daripada differentiable, we know that this function, when you not differentiate at x0, so this point is also a critical point for your graph. So in total, you will have 2 critical points. Okay, so to our conclusion. We have 1, 1, and we have 0, 2. There are critical points. So itulah berbeza sikit kita buat polynomial function dengan piecewise function. Polynomial function, you dapat, inilah contoh polynomial function, quadratic. You akan boleh dapat differentiate, dapat kosong, dapat x terus, dapat y terus, betul? Betul? Bila you datang ke piecewise function, maka you kena analisis piece by piece. Graf ni ada tak? Graf ni ada tak? Lagi satu tempat you kena analisis ialah tempat persambungan graf dia. Adakah itu jadi critical? So you kena tengok dia boleh differentiate tak kat situ. Kalau dia boleh differentiate, dia bukanlah. Kalau dia tak boleh differentiate, dia adalah critical point. Kan dia tak boleh differentiate. Our definasi kan sini ada, sama ada your differentiation get it 0 or your differentiation undefined. Dia akan jadi critical point. So tadi kita differentiation tak dapat kan? So our differentiation tak dapat. 1 negatif 2 lagi 1. Apa jawapan tadi? 1 negatif 2 kita differentiate kan? 1 negatif 2, 1 value dia 1. So it is not differentiable. So maksudnya dia punya f prime x is undefined. So bila undefined, tempat situ adalah critical point juga. Okay?